Part C. Evaluate the second derivative of y with respect to x squared at the point on the curve where x equals -1 and y is equal to 1. Alright, so let's just go to the beginning where they tell us that dy dx is equal to y over 3y squared minus x. So let me write that down. So dy dx is equal to y over 3y squared minus x. 3y squared minus x. And now what I want to do is essentially take the derivative of both sides again. Now there's a bunch of ways that we could try to tackle it, but the way it's written right now, if I take the derivative of the right hand side, I'm going to have to apply the quotient rule, which is really just comes from the product rule, but it gets pretty hairy. So let's see if I can simplify my task a little bit. I'm going to have to do implicit differentiation one way or the other. So what if I multiplied both sides of this times 3y squared minus x? Then I get 3y squared minus x times dy dx is equal to y. And so now taking the derivative of both sides of this is going to be a little bit more straightforward. In fact, if I want, I could, well actually let me just do it like this. And so let's apply our derivative operator to both sides. So let's give ourselves some space. So I'm going to apply my derivative operator to both sides. I'm going to take the derivative of the left-hand side with respect to x and the derivative of the right-hand side with respect to x. And so here I'll apply the product rule. First I'll take the derivative of this expression and then multiply that times dy dx, and I'll take the derivative of this expression and multiply it times this. So the derivative of 3y squared minus x with respect to x, well, that is going to be, so if I take the derivative of 3y squared with respect to y, it's going to be 6y, and then I have to take the derivative of y with respect to x, so times dy dx. As we say, if this is completely unfamiliar to you, and I encourage you to watch the several videos on Khan Academy on implicit differentiation, which is really just an extension of the chain rule. I took the derivative of 3y squared with respect to y, and took the derivative of y with respect to x. Now if I take the derivative of negative x with respect to x, that's going to be -1. Fair enough. And so I took the derivative of this, I'm going to multiply it times that, so times dy dx. And then to that, I'm going to add the derivative of this with respect to x. Well, that's just going to be the second derivative of y with respect to x times this. And all I did is apply the product rule. 3y squared minus x. Once again, I'll say it the third time. Derivative of this times this plus the derivative of this times that. All right, that's going to be equal to, on the right-hand side, derivative of y with respect to x is just dy dx. Now, if I want to, I could solve for the second derivative of y with respect to x, but what could be even better than that is if I substitute everything else with numbers, because then it's just going to be a nice, easy numerical equation to solve. So we know that we want to figure out our second derivative when y is equal to 1. So y is equal to 1, so that's going to be equal to 1, and this is going to be equal to 1. X is equal to -1, so let me underline that. X is equal to -1, so x is -1. Are there any other x's here? And what's dy dx? Well, dy dx is going to be equal to 1 over 3 times 1, which is 3, minus -1. So this is equal to 1/4. In fact, that's, I think, where we evaluated in the beginning. Yep, at the point -1, 1. At the point -1, 1. So that's dy dx is 1/4. So this is 1/4. This is 1/4. And this is 1/4. And now we can solve for the second derivative. Just going to make sure I don't make any careless mistakes. So if 6 times 1 times 1/4 is going to be 1.5, or 6 times 1 times 1/4 is 6/4, minus 1 is going to be, so 6/4 minus 4/4 is 2/4. So this is going to be 1/2 times 1/4 times 1/4, that's this over here, plus the second derivative of y with respect to x. And here I have 1 minus negative 1. So it's 1 plus 1, so times 2. So maybe I'll write it this way. Plus 2 times the second derivative of y with respect to x is equal to 1/4. And so let's see, I have 1/8 plus 2 times the second derivative is equal to 1/4. And let's see, I could subtract 1/8 from both sides. So subtract 1/8, subtract 1/8. These cancel. I get 2 times the second derivative of y with respect to x is equal to 1/4 is the same thing as 2/8. So 2/8 minus 1/8 is 1/8. Then I can divide both sides by 2, and we get a little bit of a drum roll here. You divide both sides by 2, or you could say multiply both sides times 1/2. And you are going to get the second derivative of y with respect to x when x is negative 1 and y is equal to 1 is 1/16. And we're done.